Hi everyone, welcome back. Let's write some more Leetcode today. Today we are solving evaluate reverse polish notation. I will go over two ways to solve this problem, but we'll only go over the code for the optimal solution. If you're only interested in the optimal solution, then feel free to skip to the timestamp. So the problem states that we are given an array of strings and the array is named tokens, and it represents an arithmetic expression in a reverse polish notation. And we want to evaluate the expression, and we will return an integer as a result, and the integer will represent the value of the expression. And we should note that the only valid operators there are the plus sign, minus sign, multiply sign, and the divide sign. And each operand may be an integer or another expression, which are these four operators. And the division between two integers will always truncate towards 0. And there will not be any division by 0. So we don't have to worry about that. And the input represents a valid arithmetic expression in a reverse polish notation, which we will go through in these examples. And finally, the answer and all the intermediate calculations can be represented in a 32-bit integer. So we don't have to worry about the sum or product going past 32 bits. Looking at this example, we will go through the entire array, and as we go through, we want to check if it's an operator. If it's an operator, then we compute the operator with the previous two operands. So as we can see, we would first do 2 plus 1, then we will do 3 times 3 because 2 plus 1 equals 3, so 3 times 3, and the result would be 9. In this example, we will first do 13 divided by 5, which is 2, then we will do 2 plus 4, which equals to 6. So how can we solve this problem? One way that we can solve this problem is we can loop through the entire array, and as we loop through, we want to look for the first operator that we see, and as soon as we see it, we apply that to the previous two integers, and then we continue this algorithm until the length of the array is 1. So let's go over this example. 9 plus 3 is equal to 12, so we apply that, and 12 is here. 12 times negative 11 is negative 132, so that's why negative 132 is here. And then 6 divided by negative 132 is 0, so now we have 0 in the array. And 10 times 0 is equal to 0, so we have 0 here. 0 plus 17 is equal to 17, so we have 17 here. And 17 plus 5 is equal to 22. And now the length of the array is 1, so we return the element that's in the array, which is 22. So we will return 22 for this problem. So the time complexity of this would be O of n squared, because the algorithm will have a while loop that waits for the length of the array to be equal to 1, and then it will also have a for loop nested in it that's going through the entire array. So there's actually a more efficient way to solve this problem, and we'll go over that way right now. So the more efficient way to solve this problem is we can have a stack, and how it will work is that we will loop through the array, and as we loop through, if the element is a number, then we just add it to the stack, and if it is an operator, then we apply the operator to the last two elements of the stack. And we will continue this algorithm until we get to the end of the array. And then by the time we get to the end of the array, there will only be one element in the stack, and that will be what we return. So let's go through this example. So we will add 10, 6, 9, and 3. So now we come across an operator. We will apply the operator to these two. So 9 and 3, we add them together. That would equal to 12. So 12. And then now we add negative 11. And then now we come across the multiplication operator. So we apply to the last two elements, which is negative 132. 132. And then now we have the division operator. If we divide this, it's 0. So this equals to 0. And then now we have the multiplication. So if we multiply these two elements, now this becomes 0, and then now we add 17 to the end of the stack, and then we have the plus operator. We add these two, equals 17, and now we have 5, so we add 5, and then now we add 5 to the end of the stack. We add these two, it's equal to 22, and now that we have come to the end of the array and there's only one element in the stack, so we return 22. And the time complexity of this would be O of n, because we need to loop through the entire array, and the space complexity will also be O of n, because we are using a stack, and the stack can take up to n space, where n stands for the length of the array. So now let's get to the coding part. So first we will create our stack. Then we will create a for loop for the array, which is called tokens. And we'll check if it's equal to plus sign. If I is equal to plus sign, then we want to append the last two elements of the stack. So stack.pop plus stack.pop plus stack.pop. And if I is equal to the minus sign, then we want to subtract the last two elements, but we can't just do it like the plus sign. The order actually matters, so we will set the variable to 1 for the last element and 2 to the second for the second to last element. So then stack will append 2 minus 1. Else, if I is the multiplication operator, then we will just multiply the last two elements. So stack.append, stack.pop, multiplied by stack.pop. Otherwise, if it is divide, then we would also do it like subtraction. So 1 is equal to stack.pop and 2 is equal to stack.pop for the second to last element in the array. And then finally we will append it, so stack.append, but make sure we floor it, so int of 2 divided by 1. Else, if I is not any of the operators, then we just append the int of I. And by the end, there will only be one element, so we just return the stack of 0, which is the only element in the stack. Let's see if it works. Okay, perfect. Thank you all for watching. I hope this was helpful. If you have any questions or comments, feel free to leave it down in the comment section below. And I hope to see you all again soon.